Hi, and welcome to session 7 of the grade 6 course. As always, we are going to start off with a little recap. Okay, so I want you to pause, have a go at all those questions, do as much as you can from memory. Hopefully, we're now getting to a stage where we're able to recall those methods and give them a good go. That said, if you get stuck, obviously look things up. All right, and hit play when you're ready. Okay, so there are your answers. Now you can see that I have highlighted the worded simultaneous equation. Hopefully you've had a good go at that. I'm just going to talk us through that one. Hit pause, check everything else, and then hit play, and we'll go through the choose and bubbles question. Okay, so before we do that, I just wanted to point this one out. If you're being asked to solve a quadratic and give your answer to 3 significant figures, there's absolutely no point in trying to factorize first. You would know straight away that it's going to require the quadratic formula. This just needed to be rearranged. So if you missed that, that's important. Quadratics have to equal 0 in order for us to solve them. Okay, so I just thought I'd point that one out. Okay, so over to this one. We've got 3 chews and 4 bubbles that cost 72 pence. So we've got 2 things that add together to make 72. And that is kind of what I'm looking for when I'm reading a question and then my brain is thinking 2 things, 2 different things. That's got to be simultaneous equations. So I've got 3 chews and 4 bubbles that add together to equal 72. I've then got 5 chews and 2 bubbles that's going to equal 64. Now, our method is always to get these the same, always. So I would multiply by 5, multiply by 3, matching my 15, and away I go. And if you did that, you absolutely did everything correctly. I am going to be doing something slightly different though. Just because 3 chews was mentioned first in the sentence, it doesn't mean that the chews absolutely have to be at the beginning. There's nothing to say that I couldn't have written the bubbles first. And of course, if I write the bubbles first, so 4 bubbles plus 3 chews equals 72, and 2 bubbles plus 5 chews equals 64, that's still true. But now, when I get these on their own, when I get these to match, get them on their own. When I get these to match, I've only got to work on this bottom one. I've only got to multiply that one up by 2, and I'm matching straight away. So what that's doing is it's preventing the numbers getting too big. So it's more manageable. Now, it makes no difference if it's on a calculator paper and you're using a calculator. But if it was in a non-calculator paper, this would be quite a nice little trick to do. So it is what we are going to do. To sort of finish this off. Oops, that was too big a rubber, wasn't it? Let's just get rid of that and move this up so we've got a bit of space. There we go. Now, if I multiply the bottom by 2, that's going to give me, keep the first, so 4b plus 3c equals 72. And then I've got 4b plus 10c equaling 128. When I do my take, and I should always be looking at that ring there to make sure nothing is being changed through the signs. Then I've got 3 take 10c, which is minus 7c, equaling 72 take 128. That is going to be minus 56. And then when I divide through by that minus 7, c is going to equal 8. Okay, so I might just rub out some of this here. So I've got some space to work in. I think that will be easier than trying to squash it all in there. Okay, so now I know c is equal to 8. I need to just choose an equation. I'm just going to go with 4b plus 3c equaling 72. Okay, I know that my c's are 24, so I've got 4b plus 3 times 8, 24. That's why I said 24 equals 72. Okay, we'll take off the 24 to give me 4b equals 48. Divide through by the 4, and b gives me 12. Now, the actual question is asking me what would 3 chews and 5 bubbles cost? Well, I've put all the legwork into finding the cost of a chew and a bubble. And now I will just finish it off by literally saying, okay, what would 3 chews cost? Well, 3 chews would be 3 times 8, and 5 bubbles would be 5 times the bubbles was 12. 24 plus 60 is equal to 84 pence. So if you've got 84 pence, doing it by multiplying by 3 and 5, getting those 15 C's, absolutely correct. Nothing wrong with the way that you did that. It got you the right answer. Happy, happy days. I was really just trying to demonstrate how you can kind of manipulate things to make things work for you. And if it was on a non-calculator paper, you would want to keep those numbers as low as possible. All right. Okay, so we are now in the world of circle theorems for the next 2 sessions. Okay. Now, circle theorems is using facts to help us solve mainly angle questions, but actually we can bring some length work into this as well, which we will see. It's extending on from all our other geometrical properties that we know. And what I mean by that are angles on a straight line equal 180, triangles 180, parallel lines have alternate and corresponding angles, angles around a point. All the angle facts, which are our geometrical properties, are learnt and built on. And this is just building now on that with an additional 9 facts. So in our circle theorem topic, we have an additional 9 facts that can be used and applied to various diagrams to try and solve missing angles. And like I say, sometimes we can do that to lengths as well. So it's big, really, really big. And I see lots and lots of students struggle with it when they start off, because learning 9 new facts, then trying to identify them in a diagram with lines all over the place, that can be really, really hard. So if you struggle for a little time doing this, know that that is normal and don't worry about it. All you actually have to do is give it 100%. Just keep trying. Don't give up. Don't get to that stage where you think, oh, I'm never going to get this, because you really, really will. It's new and it takes time. So you have to be really, really patient with yourself. So throughout this session, okay, where we're learning the first 4, you're going to try every single question. This is not about watching me do it. You're going to try every single question. If you get tired, if it's going on for too long, you're going to just stop and then pick it back up when you're ready. And and just go for it. So the first bit is me introducing these 4 circle theorems to you. I would really strongly recommend, if you don't normally, you make notes. You should make notes anyway. It gives you things to look back on. But for everything I go through now, pause, make your own notes, hit play, keep going, get all the information down so that when you're having a go at some of the questions in a minute, you've got notes to look back at yourself, okay? All right, so let's start with angles at center is twice angle at circumference. So what do we mean by that? Now, I'm going to be trying really hard to show everything as clearly as possible on the software that I'm using. Hopefully it will come out pretty well. So angle at center is twice angle at circumference can look like this. So I've got a point on the circumference that goes up to the center and another point that goes up to the center. And actually that is critical to understanding this theorem. It's all about 2 points. okay? From those 2 points, I can travel to the center. I could also, from the exact same points, travel along some completely different lines to the circumference. And doing both those things, going from this point here to this point here, or going from this point here to this point here, creates me 2 angles. I have an angle at the circumference. I have an angle at the center. And the angle at the center is twice the size. And you can actually see that, you know, when you look at that diagram, it does look twice as big. So if this was X, this would be, 2X, twice the size. Or you can think of it the other way around. The angle at the circumference is half that at the center. Now, you have to be really, really careful with this, because if you just start looking for a shape that looks a bit like an arrowhead, then you will limit the way that you will use this, okay? If I was to put a line between those 2 points, doing my best, you can see that the software has just come off the circumference a little bit. I wanted it on the circumference at that point, really. But if I do that, suddenly the diagram looks and feels a bit different. And just something as small as that can help us miss. So what I would be looking for when I'm problem solving is I might be looking for a chord, and it's the 2 points at the end of the chord that's going to direct me in and through the diagram, okay? We need to learn the language. Center is twice that at circumference, something along those lines, because if they say give reasons, we need to give reasons for why we're saying the angle is what it is. So for example, if I was to say that this angle was 80, I would be saying X is equal to 40, and then stating because the angle at the center is twice angle at circumference. It's a bit of a mouthful, and it's quite a lot to write down. If you are struggling at any stage with just working through those diagrams, then make that your first job, and then make writing about it your second job. If you write as you go, it may be easier to do and be a bit more natural, but you need to break the learning up if that's going to help you, okay? So I was talking about the shape, wasn't I? The shape is important. So let me just give us a new circle. The shape is important because it can vary. So let's just say I've got 2 points on the circumference. So I've got that point there, and let's say that point there. I can draw a line to the center from those 2 points, which I'm going to do, just setting everything up. So we're going from there to there. And I can go to the circumference. Now, on the last example I gave you, I was up here, wasn't I? But I can be anywhere on the circumference, and this works. So let's say I'm going to go over here. And hopefully, as I say, it will actually do this for me. So there to there. There we go. That's quite good. That's not so obvious at all. It certainly doesn't look like an arrowhead anymore. But the fact is that from these 2 points, I can travel along a pair of lines that take me to the center. And I can travel from the same points along a couple of lines that take me to the circumference. So the angle at the center is twice the size of the angle at the circumference. So that is a favorite of the examiner because it can look so different. One of the things that I would encourage you to do is to use your fingers. So obviously I can't demonstrate this particularly well, but what I would do is I would literally put my fingers on the 2 points, and then I would travel along lines and see where they take me. And that can be a really useful way of being able to identify there's 2 points. What do they do? Oh, they do this, or oh, they do nothing. I'll look at 2 different points. It's a bit like being a detective when you're doing work with angles. They give you a busy little diagram and you've got to pull out all the clues. Everything you need is there, but you've got to pull out all the cues. All right, so that's the first one. Let's now look at the second one. So we will highlight it for your notes. Okay, she says, there it is. So angle at circumference from a diameter is 90 degrees. So let's have a look at what we mean by that. First of all, a diameter is a line that goes right through the center. So it's got to go through that center point. Okay. Any other line, let's say I go, oh, it's Daisy, sorry about that. Let's say I go from here to here. That is a line that goes from one edge of the circumference to the other, but it isn't going through the center. So it's called a chord. All right. If I have a diameter and then I go up to a point on the circumference, so let's go up to there and do it from there as well. Oops, that just about worked. That looks a bit curved to me. I don't like it. Let's try again. That's a bit better. That angle hitting the circumference is always 90 degrees, always 90 degrees. It doesn't matter if I'm hitting it here, if I'm hitting it here, I could be hitting it anywhere, literally anywhere on the circumference, and it will make me 90 degrees. I'll go to one of the points that I've just drawn so that we can see, hopefully, that working. So I'm going to go from here to here, and then from here to here, and hopefully you can see that that is looking pretty much like a right angle right in there, because it is. I would never assume it, but because there's a fact, a circle theorem that says diameter to circumference is 90 degrees, then I can use that fact to help me problem solve. Okay, so that's the second one. The third one, angles at a circumference in the same segment are equal. Okay, so let's see what they're talking about here. Now, for this one, I don't need the center point, so I'm going to get rid of it. And I'm going to put a chord onto my circle. So I'll just shove one in there. There we go. When I split the circle into two sections by putting a chord in, I could do it with a diameter as well, but I want to do it from a chord for this particular theorem. When I split it in two, what I'm doing is I'm creating two segments, and that's important for us to understand. So I have a segment this side, and I have another segment this side, okay? This theorem is saying angles at circumference in the same segment, okay? So let's have a look at an angle going up to the circumference from this segment. So we're going to go straight up here, and then I'm going to go up, hopefully in a straight line to join it. That is an angle at the circumference drawn from a chord. If it was drawn from the diameter, it would be 90 degrees, but it's drawn from a chord, and I can clearly see that that 90 degrees is now lost, and it is another angle size. If I choose to go to another point, so let's say over here, I have created two angles at the circumference in the same segment, which means those two angles are equal. So if that's X, that's X. And do you know, I could do that as many times as I like. I could, oh, don't know why it does that. Let me undo it. There we go. I could go up to here, and that would be X. So I can do that as many times as I want. So again, this is where those fingers are really, really handy. I literally put my fingers on the 2 points, so the end points of a chord, and up I go to the circumference, up along 2 different lines. If I land at a circumference, then I've just found 2 equal angles, okay? And the same thing would happen if I was going off in this direction into this segment, okay? They would be equal as well. So that's a really handy problem-solving one for us to know. Okay, let's have a look at the last one that we're going to be looking at. This one here is opposite angles of a cyclic quadrilateral. So big mouthful, add up to 180 degrees. So let's get a circle in. A cyclic quadrilateral is exactly what it sounds like, okay? It's basically a quadrilateral that has its 4 corners or vertices on the circumference, okay? Really important that they are all on the circumference, because diagrams can create where you've got crisscrossing lines. They can create quadrilaterals all over the place, but you must only use this if those 4 corners are on the circumference. I can't stress that enough. I've said it enough. Okay, so let's draw this one in so that we have a full example of it. So we're going to go from there to there. Oops, not perfect. From there to there. It's very sensitive, this. There you go. Look, that was rubbish. Let's undo that and try again. Not too bad. Not too bad. Not perfect. Okay, we'll label them up A, B, C, and D. And then they must add up to 180. Okay, so A plus C is 180 and B plus D is 180. I think the most common thing that I see is people thinking they equal each other. So like if B was 50 degrees, they would be saying that D is 50 degrees. That's the most common mistake, kind of mix up that people make, that they try and have them equal each other rather than that they add together to make that 180. But it is add, okay? Add to 180. Okay, so those are all the facts. They're the theorems, the first 4 of the 9 that we are going to learn. And we are now going to see them in a problem-solving situation rather than just talking through what they look like. Now, as I flick through each page, you will get a slight flicker in the video. There's nothing wrong technically with the video. It's just I can't make it any smoother, sadly. So it is going to do that on us. Right, here is the first 2 questions that we're going to look at. I want you to just do the first one, use your notes, press pause. I want you to try and give me the angle, size, and the reason. Okay, we're going to try and reason all the way through at the same time if we can. All right, so hit play when you are ready. Okay, so I've got 2 points, okay, and when I travel along those lines, I go to the center. When I travel from the points along these lines, I go to the circumference. So X is going to be 28 times 2, which is 56. So if you put 56 down, you got that right. And then you would write something along the lines as angle at center is twice that at the circumference. I'm going to be lazy, at the circumference. So if you did those 2 things, brilliant, well done. So now I just want you to hit pause, have a go at that question, and then hit play when you're ready. Okay, so for this question, I can see that a line is going right through the center point. So I know I'm looking at a diameter. That means that the angle coming off from the end of the diameter is going to be a right angle. They're also telling me that this triangle is isosceles. I know that because of these 2 lines here, which means this angle and this angle are equal. So I've used, you have to decide, you could tell me pausing there, you have to decide whether you want to do all the work and get your X and then talk about what you did, or talk about it as you go. Now I'm a talk about it as you go kind of girl, because then I won't forget what I've been doing. So the first thing I've done is I've done diameter to circumference is 90 degrees. I've used that fact, so I'm going to write that down first. I've then noticed that an isos triangle is part of this diagram. Okay, so isos triangle has been used. 180, take away the 90 I know gives me 90. 90 divided by 2 equals 45. So x is equal to 45 degrees. And the facts are clearly written down for the examiner as I went along, and that would be good enough. All right, so one of the things that I want to point out that I've done, I can't promise I do it all the time, but it's definitely what's going on in my head, is I'm always looking at points. And when I see a couple of points, I'm going to test them out. But you can see I highlighted them. I didn't just do that to help communicate what was happening between me and you. I do that anyway because it stands out, it's popping out the diagram, it's helping me stay organized in my head and help me just go through what it is I'm planning on doing. So when I have this diameter, I highlighted the whole thing. Really common again for me to do that because a diameter has a very special rule and I want to be able to use that rule if a diameter is there. So it's good to highlight that. All right, hopefully it's going okay. These are the next two. So obviously we'll work on this one first. So have a go and hit play when you're ready. Okay, so I know that I've got two diameters actually in this diagram. This is my center point, which I'm making really clear with a big dot. A GCSE question might label it O, or they will reference it when they write about the diagram that you've got the center given to you. So I've referenced that really, really clearly with a big dot, basically. So I know that I have my diameter rule, don't I? So I could look in all sorts of directions. I'm going to do this one, which means that going up here and here, I have a 90-degree angle. Now, I know that some of it has already been labeled up as 35. So if I do 90 take away 35, I will get 55. So that means this side is 55. Now, before I do anything else, I'm going to be writing down my reason. Otherwise, I'm going to forget to do it. I'm just going to get so engrossed in doing the angles that I'm going to forget that I'm supposed to be writing my reasons. So I used my circumference diameter equals 90-degree rule. And the rest is self-explanatory. I don't need to write what I did there. Okay. Now, the other thing that I have to spot for myself is that I'm going to do it in a different highlighter, but it will start to get a little bit messy. Okay, this line here, from here to here, okay, that is a radius. It's going from the center to the edge, which means that this is a radius. This line here is going from center to edge, which means that this is a radius. If I've got the two radii there, then I've got two lengths that are equal. So although they haven't done it for me, I do know that this edge and this edge is the same length, which means I'm looking at an isosceles triangle. So that sneaky little isosceles is popping up all over the place. So you've got to really watch out for that. So I can use the fact that I've got an isosceles triangle, which also equals 180 degrees, to finish this problem off. X must equal 55 degrees. Okay, so if you got that right, really, really well done. If you missed that isosceles, perfectly normal, don't worry about it. You will see that we use a lot of our basics in amongst using the circle theorems as well. So watch out for that, look for them. Okay, next question. Literally pause and hit play when you are ready to see how you've got on. Okay, so the first thing to note with this particular one is I don't have a diameter marked in. Okay, that does look slightly off, but I must never assume anything. Okay, so without the markings of a center point, then I don't have a center point, which means I don't have diameters here, and I can't go on and use that fact. So that rules that one out, if you like. Now they have marked on an angle here, which is 66. So the chances are that this angle's got to help me somehow or other. They've also marked this one on 105. However, this angle of 105 is spread across 2. So that's not going to be quite as useful. I can see by looking at it that I've got a cyclic quadrilateral. So there would be nothing wrong in trying to see if that was going to help me as well. But with all the splits here in the corners of every one of the angles, it's less likely to be useful. So I probably wouldn't go down that road first off. What I am going to do is I'm going to focus in on this, because this is a single angle that's been marked up with a value. So the chances are that's going to be useful. And I'm going to look at the 2 lines that make this angle, because what it will do, and I'll do it obviously with my highlighter, what it will do is it will take me to a point. Okay, so if I go down, that takes me to the points here and here, which means I can look to see whether there are any other lines growing out of these points that will take me to something useful. It might take me to a center, it might take me to another part of the circumference. So let's have a look and see where it goes. This takes me up over here, and this takes me to another point on the circumference. Now remember, we are using the same segments are equal here, because I've got my chord. Oops, actually, let's not do it with another highlight. Let's just do it with this. I've got my chord here, and these angles here and here are in the same segment. They're this side of the chord. So I can use that rule for that reason. Hopefully I'm explaining that well. So if that one there is 66, this one here is 66. Okay, so I've used, and I'm writing it as I go, same segment are equal. Now in a diagram, a GCSE diagram, a lot of things are labeled up like O, A, B, C, D, and then you can say angle OAB equals 66, same segment. Okay, we're just reducing the busyness of the diagram whilst we're learning it. All right, but we will see that and we will use that notation later on. So same segment are equal. I've used that rule to get 66. And then I can see that I could work out this one here. Kind of, for me, it's like you've given that to me for a reason. I don't know what that reason is yet, but you've given it to me for a reason. If I've now worked out that 166, I can work this one out. Will it be useful? I don't know yet, but we're going to check it out and see. So I'm going to do 105 take away 66. So 105 take away 66 is 89. Okay, and now I can label that on. Always, wherever possible, label up your diagrams. Okay, so there is, I love doing it this way because it's a way, rather than just testing out loads of 2 points, it's a way of just taking yourself to 2 points that might be significant. So this angle here is 89. If I take myself all the way down to the circumference, then I've got, and I'm going to do a different color here, then I've got my 2 key points. So if I go away on some different lines, I can go to that same segment rule, and the X here is in the same segment as this angle here, 89. So I can now say that my X is equal to 89 degrees, and I use the same segment rule for a second time. So I might as well write it down for a second time. I don't want to give my examiner any reason whatsoever to not give me my marks. Okay, so they're the first 4 examples. Hopefully it's going well, fingers crossed. Even if you're not getting all the way to the end, if you're picking out bits and you're seeing bits, then you are making progress with this as a topic, because it's a lot to do. One of the other things that I must point out is for some, there is only one way to do it. But for other questions, you can work your way around in a different way and still get the same answer. And I think that's really important to mention, because if you get the right answer, but you do it a completely different way, you may now think that what you've done is wrong and it's just luck that you got your answer. It won't be. If you've got the same answer and it's right, then the chances are much more likely to be you just found a different way around the diagram. As long as you talk through what you do at every stage to back up and evidence your reasoning, the examiner's still going to give you full marks. Okay, so if as we work through this topic, you do get the right answer a different way, please don't think that you have done it wrong. It just means the way that I have viewed the diagram is different to the way you have viewed the diagram. Okay, so we have some more. I want you to pause, hit play when you're ready. Do the first one for me. Okay, so hopefully this was nice and easy. Opposite angles add, just remember it's add to 180, okay? So if this is 30, this has got to be 50. So A is equal to 50. And then if that is 85, then B, again, it's got to add up to 180. So B would be 95. And I would literally just write cyclic quad op adds to 180, something like that. I'm quite lazy. I'm going to write as little as I possibly can, but make sure I get the point across. All right. Now, remember, these are not drawn accurately, so you must never try and make the angle and the size that we're coming up with necessarily fit. Okay, because it won't always work like that. Okay, hit pause, have a go, and play when you're ready. Okay, so the first thing to do is just to take your time with everything that you've got going on in this diagram, because there is a lot going on, okay? I can see that I have a set of parallel lines. Now, if they've given me a set of parallel lines, they've done that for a reason. So the chances are I'm going to be Z or alternate angles, something's going on here, okay? So let's have a little look. I can see that I've been given this angle here. If I travel on down and make that Z shape, then I've got an alternate angle and I've got K is equal to 89, literally just K is equal to 89, and I used alternate angles. I'm going to write that small because I'm running out of space. Didn't use a circle theorem at all, and you can. So K is equal to 89. Now I know that opposite angles, so I know K and A have to add up to 180 because of my opposite angles rule. So A is going to equal 91 degrees. My degree sign in there as well. And I can obviously write op adds to 180, cyclic quad. Okay, so I've justified what I've done there. So I found two of them now. Oops. And then to finish this off, there's various different ways, to be fair. I think what I'm going to do is I'm just going to use my straight line rule to get 91 there. So straight line equals 180. And then I've got that equaling 89 because of the opposite cyclic quad rule. Okay, so if you got those, fabulous, well done. Let's look at the next set of questions. There we go. All right, so have a go at this one first. Take your time and then hit play when you're ready. Okay, Right there, this is a busy diagram, isn't it? Okay. Now I've got a center point and I've got an angle marked here. Okay. So if I go down those lines, I get to my points on the circumference. If I go along, I get that rule, the first one that we used, which was the center is twice the angle at the circumference. Okay, so if that's 98, then this is going to be half that 98, which is 49. So x is going to be equal to 49. And we would write down something along the lines of angle at center twice angle at circumference. Remember, writing it down as you go means you never have to think about it again. You can just move on now to the next thing that you're going to try and spot with this particular, okay, with this particular question. So I've also got 1, 2, 3, 4 points on this quadrilateral, on this circle, making a quadrilateral. Let's highlight the quadrilateral that that makes. There it is. So I know that the opposite angles of a quadrilateral have to add up to 180. So this angle here is going to be 180. Take away the 49, okay, which is equal to 131. So I know that's 131. And then it's fairly obvious from here. I'll go through the whole thing, but I think it's fairly obvious from here. Then I've got a straight line here. So that bit there, my y is going to be equal to 180 minus 131. So I'm kind of reversing things. So that is going to be 49 degrees. Okay. So I used here cyclic quad rule, and I used here straight line rule, and I got to where I needed to go. And as I say, you know, some of these can give alternative ways of doing it, and if you got your answer right and fully justified it, then all is good. Okay, so let's not do that. I don't think it's going to work. Okay, on to the second question, and hit play when you're ready, please. Okay, so what am I looking at? They've given me the center point, but there's no lines going through it, so not a useful piece of information. I can see here that I have a cyclic quad, so I can work out my y fairly easily. So I might as well do that one first. So we've got 180 minus 118. That's going to be 62 degrees. So y is 62 degrees, and it's a cyclic quad. I'm not going to write the whole sentence, but you want to write as much as you can to show you that you understood that. Okay. There is a really simple way now of finishing this off if you spot it. Okay. So I have a triangle here. I know that that is 62. I know that is 68. So I've got 62 plus 68, okay, which is 130, and 180, take away 130, gets me my x equals 50. And actually, I used triangles add to 180. That was what I used. Okay, you could have gone straight line here and followed another pathway, but that was the one that I saw when I looked at that diagram. Okay, let's do, oh, we've run out on that page. Okay, no worries, I have more. All right, these are the last 4, okay, and then we're going to finish that session there. All right, so there's no kind of sheet at the end for you to work through. It's literally do a question, I'll go through it with you, do a question, I'll go through it. So this is the last 4. All right, so hit pause and have a go at that first question. Okay. There is a lot happening in this particular question, okay? I'm going to take it in, first of all, because I can't digest all of that information unless I just stop and take my time. So I'm going to look at what they've given me, first of all. So I know that this here, oh, let me go to a pointer. I know that this here is 20 degrees. I know this here is 29 degrees. I can see some triangles. I can see some quadrilaterals. I can see a same segment. That is actually standing out quite well for me. If I look at these 2 points here, if I go along these lines, I hit to that angle. And if I go along these lines, I hit to that angle. Now, I don't know if that's going to be useful or not, but I can see it. So what I'm going to do, because I can see that, is I'm just going to mark it on that those 2 angles there are equal. Just by marking the angles with a color, that will remind me that I spotted that, because obviously once I get going with this, I may very well lose sight of what I'm doing. Okay, so where shall we begin? I think what I'm going to do with this one is start with a triangle that I spotted, okay? Because I have these 2 angles here, and I have this particular triangle, so going all the way here to here, I've actually got 2 of the angles that I need, and it means that I'm going to be able to find X just using an angle rule, which is quite, the triangle rule, which is quite nice. So I've got, I'll do it over here, 20 plus 29, which is 49. And then the 180 take away 49 is going to give me 131. So my X is 131. Okay. And all I did there was use triangles equal 180. So that's all I would write down for that. Okay. Let's pull this up a little bit. There we go. Okay, so I've got that. I now know that I can find this angle here because I can use a straight line. So 131, so 180, take away the 131 is 49. So I know that this angle here is 49, which means I know this angle here is 49. I'm just marking it in because I know that I want to get it down whilst I'm thinking about it. I want to be trying to get to Y. So I think what I'm going to do is I'm going to use this 49 here to help me, because I can see a triangle and I've got 2 pieces of information, which is going to help me find this one, which is opposite my Y. So I am using this one. I know this one because of the alternate segment. So I'm going to write that down. So I've got alternate segment has helped me get that 49. I'm now going to do 20 plus 49 is 69. All right, so 20 plus 40 is 69. 180 take away the 69 is going to give me 111. Okay, I've used triangles equal 180 for that bit. So that's that. And then Y is equal to 111 degrees because of vertically opposite angles. Okay. Now that is not the only way to do that. That is just the way I saw it in that moment. And if you did it a different way, remember that it's absolutely fine. It's a big question, lots of lines, which just creates lots of opportunity to find a route around to the answers that we want to get. Okay. Next question, please. Hit play when you are ready. Okay, just cleaned this sheet up a little bit so that we've got some space. All right, first thing I've spotted, I've got my center point and I've got my line going through it. So I've got a diameter. I'm going to highlight that in case it's useful. Okay, is it going to be useful or not? It's not, is it? If I go up here, I can't come down to this side along a line that I've been given, because there isn't one there. So none of these are going to work to give me 90 degrees. So the diameter is there, but it's not massively useful. So this one is a cyclic quadrilateral. Yeah, I've got my 4 corners. So my opposites are adding, okay, to 180. So y is going to be 180 take away 42. 180 take away 42 is 138. And x is going to be 180 take away 85, which is 95. They both come from the cyclic quad rule. So if I was going to write that out properly, I'd be writing out angles opposite add up to 180 in a cyclic quadrilateral. All right. You'll be happy to know we're on our last 2. Okay. So hit pause and press play when you are ready. Okay, so we got a lot going on in this particular diagram. So let's start taking things in. So I have a center point, so I definitely have a diameter. Just going to highlight that. What else am I looking at? I can see that that diameter is going to work, so I'll mark that probably on in a minute. I can see parallel lines, so I could have alternate and corresponding angles coming into this. I've got to obviously find x and y. They've given me an angle here, which could be useful. It's sitting on a straight line, so I could bring a value in here if I needed to. So that would be good. Okay, so let's have a go at what we can see going on. So first of all, I can see that there is my 90 degrees. Okay. I don't know if that's going to be useful or not, but it's there. Okay. I know that this here is going to be 180 take away 76. So that is 104. So 180 take away 76. Used a straight line rule there. Used my circumference and my diameter rule here. Okay, so what else do we have happening in this? I have a cyclic quadrilateral. Can we see that? I've got 1, 2, 3, 4 corners on the circumference, which means that this angle here is opposite this angle here. So I have enough to help me find that one. So if I do 180 take away 104, I will get 76. And I've used my cyclic quad for that one. Now I can find x, okay, because I have my triangle. I know that I've got the 90 and the 76. So where am I going to write this up here? 90 plus 76 is 156. Sorry, 166. And 180 take away 166 is going to be 14. So x is 14 degrees. Okay, now that y, I can work it out using the 76 that I was given. So let me get my little highlighter. That 76 there is on a z with the x and the y together. But because I now know what x is, then I can work out y. All right, I know together they are 76. But I know x is 14. So when I do 76 take away 14, I will get 62 degrees. So y is equal to 62 degrees, alternate angles. Okay, alternate angles on that one. Huge amount going on, isn't there? So many different rules, so much to see and look for in those diagrams. That is what makes them tricky. Okay, practice is what's gonna help here. Exposure. So if you are finding this hard, if you're not getting there quite yet, don't worry about it. The more we do it, the better we're going to get. What I'm hoping is that you are starting to see different things, okay? You are able to pull some of this together. It's really, really hard. So don't beat yourself up, as I said before, if this takes a little bit of time. All right, let's try the next one, okay? So when you are ready, you will hit play. Just go for it and see how you get on. All right. So when I look at this diagram, I can obviously see the X they want me to find. I can see that I have a diameter, and I can see that they've given me a single angle. It's not been kind of mixed in to stretch across two. I've got a single angle here. So I'm always marking my diameter in because I find that really helpful. And if I go up off the ends, I do go to an angle up here. So I know that that is 90 degrees. Now, I don't know if that's going to be useful to me or not yet. It's something I've spotted and I've stuck it in there. Okay. The other thing that they've given me is the 38 degrees. Now, this line and this line made that 38 degrees for me. So if I stretch it down, it will take me to two key points on the circumference. So this one and this one. If I have other lines coming out, then those lines, if they hit the circumference, are going to be equal. So it's really worth my while to check that. So if I come out along this one and I come out along this one, then I'm doing exactly that. So I can go there to get 38, or I can go there to get 38. So I now know that is 38 degrees. Now this is coming together really nicely because I've obviously got a triangle here now, and I've got two pieces of information, which means I can work out my X. So before I do that, I'm going to write down what I've done so far. So I didn't write it because I wasn't sure whether or not it was going to be useful, but it has been. So I have done my diameter circumference to get me my 90 degrees. I've done same segment to get me my 38. And now I'm going to do 90 plus 38. Okay, which is equal to 128. Do 180, take away 128, and I've got 52. So X is equal to 52 degrees. And all I used to finish that off was triangles add up to 180 degrees. Okay. So that was your first look and first session on your circle theorems. So really, really well done. It's a long session, so you've done really, really well. We're going to carry on and introduce the rest of the rules next session. And then obviously throughout the rest of this course, we are going to be exposed to these questions. By the end of the course, we will be nailing circle theorems, no problem. All right, I will see you next session. Well done today.